When working with DC circuits, it's very important that you observe the polarity of each of the loads.
The voltage drops across the loads have a polarity. The easiest way to determine these polarities is to use the direction of the electron flow as a basis. Where the electron flow enters the load, the voltage is negative, and where it leaves the load, the voltage is positive. This holds true no matter how many loads there are in a circuit. With the schematic diagram, notice that each pair of polarities applies only to the load it's near. The positive and negative for one load has no relationship to the positive and negative of any other load. Point B has both a plus and minus polarity because it is positive with point A but negative with point C. A point has to be positive or negative with respect to some other point. Placing the voltmeter from the negative terminal of the power supply to the input point of load number 1, zero voltage drop is read. Moving the positive lead of the voltmeter to the other side of load 1, a voltage drop of approximately 1.6 volts is seen. Now moving the positive lead to the positive side of load 2 produces a voltage drop of 3.3 volts. Finally, moving the positive lead to the positive side of load 3 produces a 5-volt voltage drop, which equals the 5-volt power supply.
For a current to flow through a circuit, a complete closed path is required. If there's a break in that closed path, it causes an open circuit and the current stops.
An open circuit may be caused by a broken wire, a loose connection in a switch, or a blown fuse.
It isn't always possible to detect a break in the circuit by visual inspection alone. In that case, you're going to need a voltmeter and measure the voltage across each point in the circuit.
By placing the negative lead of the voltmeter on the power supply, the positive lead is touched to each point in the circuit, starting at that same side as the negative lead and going in the direction towards the other side of the power supply. The voltmeter reads 0 volts, indicating that lamp 1 is okay.
Since there is no current flowing in an open circuit, there will be no voltage drops across any loads or devices.
When the voltmeter reads a voltage, it will be equal to the source voltage. This indicates that you have bridged the voltmeter across the open circuit and have found the trouble is lamp 2. With lamp 2 replaced, the circuit is complete and current can flow. A voltage drop can now be seen across each lamp.
Another condition that occurs in electrical wiring is called a short circuit. Whenever the resistance in the circuit or any part of the circuit is greatly reduced or drops to 0, a higher than normal current will flow.
A short occurs if voltage source leads contact each other or if two bare wires touch, or when resistance terminals are directly connected, or the wiring is improper. Notice that there is a wire across resistor number 2. Circuits are usually protected against excessive current by a device known as a fuse. Fuses are connected in series with the load and will cause a circuit to open if excessive current flows. This is the schematic symbol for a fuse.
Fuses are metal resistors with very low resistance values. They're designed to blow out and open up the circuit when the current exceeds the fuse's rated value.
When the current is too high, the power consumed by the fuse raises the temperature of the metal, causing the metal to melt and the fuse blows. Blown fuses can be identified by darkened glass and a broken filament. The purpose of the fuse is to protect electrical equipment from being damaged by excessive current. Electrical equipment such as radio receivers are expensive, but fuses are cheap. Fuses are rated by the current which they will conduct without burning out. Since various types of equipment use different amounts of current, fuses are made in many sizes, shapes, and current ratings.